Right, now let's see how arrays work as parameters in functions. Right, so we'll take a look at single, that's easy, and then multidimensional is a little bit more work, but we'll take a look at how both of those work. Right. So we can use array notation to indicate that a parameter is actually an array. Right? If we don't, it'll think it's a normal variable. So in the function header, we'll declare an array with its data type, its parameter name, and then the empty square brackets. So if this function named SumArray, we're going to probably sum up all the values in the array. So if we want to declare an array of data type float, here's the name of the array. I named it array. It doesn't have to be named array. These empty square brackets indicate that this is an array, right? Not some variable named array. And then we're always going to find out the function is going to have some idea of how long this array is. So we usually always have a second parameter that we pass to the function to let the function know how many elements are in the array. In this case, it would be named length. And the length of an array, remember, is a whole number of values. That's why its data type here is int. So the values stored in this array are of type float. This is to say how many elements this array has. So really here, if there was a function that was going to find the average of an array of integer values, data type int, right, give the array some name, empty brackets, it's okay if you leave the space here. Once again, we pass the length. There's an example with char as well. All right, so that's just how you would put that in the function parameter list. Now, when we pass an array to a function, it's a pass by reference, not a pass by value. So what pass by reference means is we're actually giving that function access to that array's memory space. And any changes we make to the array in that function will be permanent. When we go back to the calling function, we'll see that the array is changed. Right? We can't make that array point to anything else. Just as a reminder, the name of an array is a constant pointer to the array's memory location. Right? It'll probably make a little more sense when we start learning how to write pointers. But the name of an array is the name of a memory location. When we use the array notation, array at index I, whatever the value of I is some offset from the starting memory address of the array. Right. Right, so let's go ahead and take a look at how we would actually code a SumArray function. Right. So we've got code blocks here. Let's just go ahead here in main and let's just create an array of type float, right? I'm just going to call this marray, and let's say we want to store 5 numbers in it. And let's initialize all of those to 0, right? Constant value of 0. Now we're going to write a function that calculates the sum of array elements, right? We want to do that. Well, if I have everything initialized to 0, that will be very good. So we'll have to fill our array. But here, let's just go ahead and write that function. So the function, right, we were going to name it SumArray, meaning it's going to sum all the array values. We need to pass it the array. Now, we don't have to pass it as the first thing in the list, right? But let's see here. All right, I'll just call it, I'm just going to call it A. Empty square brackets means this is an array. I need to tell it maybe the length or the array size. And my return data type will be a float, right? I'm going to create a variable of type float to store the sum. So here, let's float sum, let's initialize it to 0.0, right? Floating point constant. And now I can just say for int I equals 0, start at the beginning of the array as long as I is less than the length. Remember the length, right? The last index would be at length -1. Just going to go ahead and say sum equals sum plus A at index I. Right. That will calculate the sum. The last thing this function should do is return the value that's stored in sum. Right. So now here in main, let's just go ahead. These had all zeros. That's not going to be very interesting. Let's just go ahead and fill the array with random numbers. I less than, here my length is 5. All right, the random number function is in the standard library, which is included up here. Remember, if I call rand, it's going to return a number between 0 and 32,767 guaranteed. Let's just let's just mod this by 15. Right, we should get values 0 through 14 if we do that. Remember, it returns an integer data type. So I'm going to do a static typecast to say, go ahead and take what you return, cast it to a float, and let's just store that here. Main's array is named marray. So marray at index I is the variable I have to work with. All right. So we should see that fill the array with random numbers. Now let's call then, let's just total. Right, we're just going to say total. We're going to assign to that. We're going to call our function SumArray. I'm going to pass to it marray. So just the name of the array is all I pass, and then the length here is 5. So let's see how that works. All right, let's just compile. All right, it's complaining that I'm using mod with a non-floating point type, so let's force this to return the int first by putting parentheses around it. All right, and it gives me that warning about I'm not doing anything with total. All right, we'll ignore that. All right, so let's do a run to cursor here in main. Remember, our program execution always starts with main. All right. I is local to main. We can see marray, our 5 elements were all initialized to zeros. Total has garbage in it. Right, so if we just go ahead and do next line, right, we can watch the array fill up. I changes to 0. Right, 0 is less than 5. As long as this test is true, we go into the loop. Right, so our first number is 11. We get 2, like 4, 10, 14. All right, now we filled up our array with those numbers here in main. We're going to go ahead then and do a step into, because we're calling this function. So let's say step into. We can see that the next line of code that's executed is within the function SumArray. So SumArray then, notice here, it knows about array A. See this hexadecimal number here? That's actually the address that A points to in memory. Right, that's where the array is actually stored. Right, it's actually pointing back to the data marray, where marray is stored. Right now, A is simply an alias for referring to marray. Right. And so next line, right, this sum here is local to this. It got initialized to 0. We can see now we can just step through this array. Right, length has the value of 5, simply because we passed 5, a copy of the value of 5 to the parameter length. Right, so next line, right, as we step through, it's going to access array at index 0 was 11 back in main. Right, next one was 2, right, so it's just going to access what values were in memory, add those into sum. Right, finally now we've gone all the way through the array. Sum has the value of 41. Right, we hit next line. We're at the end of our function. We're going to come back to main, so we come back here ready to execute this statement. Right, notice here, marray still has the same values in it because we didn't do anything to change to overwrite that memory. We just simply access that memory. Right, so we just read what was stored in marray. The point of this example was to show you how to use an array name, how to indicate in this parameter list that A was an array, right, how to actually then call the function. So when you call a function, right, with a 1D array, So one-dimensional array, you just pass the name of the array. So the name of the array here was marray. So that's what you use as an argument here. Right, the length we had hard-coded as 5, so I hard-coded the 5 here to pass to this. Within this function, it refers to the same area of memory with the name A, with the name we've given it here in the parameter list. So that showed us how to use a function, right, how to include a 1D array as a function parameter. Let's just stop this. Right. So we wrote this function to fill this array with random numbers. Let's just go ahead and write a function called fill array. Right. And all right, just to show you that the array doesn't have to be first in the list, I'm going to put length first, and then float A. I could call it something else other than A. Right. This function is not going to return any information. It's simply going to fill array with random numbers. That's all this is going to do. So it's actually, all it's going to do is basically take this code, I'm going to put this up here, right? That's what I wanted to happen. And here I can't call this marray, I've named it A. So I have to refer to it here as A. And here, instead of 5, I need to make this length. We don't have a return statement. We're not going to return anything. What we're going to see is this function will affect what's stored in marray. Right, so here, and we need to call the function to use it. So we call the function by name, which is called fill array. We need to pass to it. Now, since my first parameter is length, I now need to pass it the length of 5, and then pass it the name of the array here. This is just to show you you don't have to use the same order. You really want to be consistent in the way you define your function. So I normally always put the array as my first parameter, the length is my second, right? And so I can consistently call them without making mistakes. Right. Let's just go ahead and do a build. All right. So here I'm going to do a run to cursor. All right, here we are in main. Notice then main has marray. Right, so it executed these 2 lines of code above. Right, it initialized all the elements of marray to 0. But now, if we step into this function, right, we go up here, right, and now in here length has a 5. A has this address, so what's stored in A is a pointer, and addresses are stored in pointers. So A is pointing back to marray down here. We'll see that we can just step through here, right? And we're just going to simply step through the array, changing what's stored inside the array. Right. End of the function, right? We stepped all the way through. So now we come back to main, right? We come back to, and we're ready to execute the next line of code after our function call. Well, notice now after our function call, the array changed. So the contents here in main change because A points back to this and has access to the same memory. These are just aliases for the memory they point to. So it had the effect of changing that, right? We saw then before pass by value, when we had a data type that was not an array, it just got a copy of the information and didn't affect memory in other locations. But with arrays, it's a pass by reference. It affects the memory in other locations. Right? I'm just going to hit next line. Right? It would go up and calculate the sum the same as it did before. Right? So that's how we use a 1D array as a parameter. Right? We saw an example of how it's a pass by reference. In this case, this function actually then overwrites what's stored in memory. This function, SumArray, was not overwriting it. Right? We were simply doing a read of that information. So we can read and write to array memory from other functions. That's pretty much the gist then here of 1D arrays. All right, there's another example in your lecture slides about passing by reference as well. Right. All right, so there's different ways you can call or define the parameters as well. we did it the one way with the empty brackets. We can actually then write it another way. So we just use this example with empty brackets and then length. We call it length instead of array size. Well, if you want to, you can write it in this fashion, where here A is of type int, right? It's an array. We're saying it's an array because of these square brackets, but now we're saying specifically what the size is. In order to do that, this variable name, array size, has to come first in the parameter list. Right? When these parameters are declared and put into memory, they go from left to right. So the first thing in the left actually has its value initialized. So it will have a good value by the time we come over here on the right and declare the next one. I find they have limited usefulness in doing this, right? It doesn't perform any error checking in terms of whether that's a correct size or not. So if one of these makes a little more sense to you than the other, use that method. I typically go with this method and avoid this method here. Now, multi-dimensional arrays. We can't do something, you might think, since with a single dimensional array, we just use the empty square braces. With 2D arrays, we might use 2 empty square braces. They don't work like that, right? Let's come back to this. Now, let's go to a 2D array example. So let's go ahead and make M array, let's make it a 5 by 3, right? If I'm going to initialize a 2D array, then I need the double curly brackets there. All right. Let's comment out these other 2 function calls. Right? They won't work now for a 2D array. Right. Let's start with fill array. Right. So let's comment out this behavior for right now. Right. We're going to start by filling a 2D array. Right. Now, if I went back to the style of doing this, what I'm saying is we can't do this. We can't do the 2 empty brackets. So we might want to say, oh, how many rows does this have and how many columns? Right. The compiler does not like this. If I were just going to go ahead here and compile, we get an error message. Array type has incomplete element type, right? It's complaining about the fact that the length has been undeclared in this function here. Oh, it's complaining about this, right? So I should go ahead and kill that other code as well. So we just get only the warning or the error associated with this, right? We get some warnings about unused parameters now in our list, but we can't do that. This has to at least know how many columns. Let's come back to this slide, right? So when we use a 2D array, we have to go ahead and tell it how many columns it has. One way to do that is if we'd used a preprocessor directive, a macro, and define this globally in our file, then we could just use column size and our array would always be that very size. Right? So let's just go ahead, and this next example shows kind of how we can use this. Let's just go ahead and use this. We'll stick with our floats here. What we could do is up here, here's that preprocessor directive, found defined, call that call size. Now, all right, so I should make that 3. And here when I do that, I should use that here as well, so that's 3. Right, now, if I do the same thing here, now all I need to do is tell this example how many rows. It already knows that the column size is 10. Right? It's not real handy though because this is only, 10. Column size is defined as 3. It will always be of size 3. That only works if we always have something of size 3. Right? What would be better is to actually then pass, instead of doing this, right, here. Let's go back here and say our column size was our hard code of 3. Right here. Here's an example of when you really want to pass these parameters first. So now I could say something like int calls for number of columns, and then I can say calls here. All right. Now, all right, so now we don't get that compiler error. I'm getting some warnings about unused parameters. But now, right, because I define calls here, it comes into existence and gets filled in with a number before it's used here. So it has a valid value in its memory. And now this expression is sort of similar to A as a pointer to a 1D array. Right? It knows how many columns. Actually, sorry, A is still a pointer to a 2D array. It knows how many columns. Just go with the fact that you have to use this notation right now before we get to pointers. And now we still have to specify the number of rows. Because if in here, I'm going to fill a 2D array, right? I'm going to have to use nested loops to do that. And let's go with maybe R and C instead of I. So R for number of rows. So R is going to be less than rows. Right, everything's stored in row major order, so I'm going to go by rows first. Here, I'm going to say for int C equals 0, C less than the number of columns. Right. And now, I don't have to use the curly brackets because I only have the one statement, but let's be really clear about what actions we want performed when the loop condition is true by using those. So now I say A, it index R, C for my 2D array, row and column. All right, I'm still going to fill it with some sort of random number. All right. All right, we're not going to return anything. So now here, let's comment out this variable we're not using. Now let's call fill array. All right, so fill array expects the first parameter to be columns. So since my columns are 3, here, my second parameter then is actually has to be the name of the array. Here's my name of my array here. And then here's my number of rows. Let's see if the compiler likes that. All right, no complaints from the compiler. Run the cursor, let's build and see how this works. All right, so here we are. Right, now we're back in main. Remember, we always start execution from main. We've got this 2D array named marray. All right, now look at this. Right, so this tells me here, this is my row. In row 0, I have 3 elements. So we have our 3 columns. Right, their indices are 0, 1, and 2. Right, in row 1, we have 3 columns, indices 0, 1, and 2. Right, and then here, 0, 1, and 2. So we can see that all of the elements, ignore these values, these old values in black here, they were related to our last problem. That row just really doesn't have the number 11 in it. Notice everything here in red is the new value. Right? That's something they can improve upon in this version of code blocks in the debugger. But notice we have then filled everything with zeros here. We've initialized it, right, with our initializer list. So let's just go do a step into. So now here we step into, right, we're up in this function. We're getting ready then to execute this line. So notice here, right, columns got past this number 3, this first thing in the list. Columns got that value of 3. A points back to an area of memory. So this address is the pointer back to M array. Rows is 5. So as we step through this, right, it's going to then start filling in our array. Now, the thing is we really can't see this up here. Unless I were to type here, A at index 0, 0, right? Oh, and now it's not happy about that because it's a 2D array. Just be happy. Let's just live with the fact we can't see this now. Right, let's just step through. We can see R and C change, right, as we go through the rows and the columns. Not really exciting. We could do a run to cursor to get to the end of this. Right. Yeah. Sorry, if I do a run to cursor there, right, we will have filled the array with values. If I hit next line, we're going to return back to main. So we return back to main because main is where this function was called. It's ready to execute the next line. But now let's open up marray. Right. You can see those black variables, those non-meaningful variables disappear from the row numbers. Now look, all of our columns have been filled. All of our rows, all of our columns have been filled with data. So this is what we have to do for a 2D array. Right? We have to at least specify the number of columns first. We can either do it through a fixed preprocessor directive, a fixed value, or in this case, I prefer to do it like this because now this works for an array of any size. Right? Because if I happen to change this to size 2, right, now all I need to do is change this to size 2 here when I call it. Right? And this will work for something that has 2 columns. This will work for something that has 10 columns. Whereas if we had gone along with that pound define of column size, right, as 3, and then made this be that column size and gotten rid of that, it only ever works for something that has 3 columns. That doesn't make very reusable code. Right, so I'm just doing Control-Z to undo that. I go back here to the way we were. And so that's how we work with 2D arrays, right? Anyway, if we wanted to go ahead and write our sum, right, we'd have to adjust that in a similar way if we have a 2D array now. Once again, right, columns is always going to be an integer or perhaps an unsigned int, right, some sort of integer data type because it's always whole numbers. Now float, right, we have the empty brackets, then we have to say calls to let us know how many columns, and then we change the length here to rows, right, and all right, I'm going to do a copy paste here to keep my row and column notation. Right. Here we're just going to say that sum is equal to sum plus what's stored in that array. We'll code this back in now before we call it, right? We've got to pass it the number of columns. Right. So if we do a run to cursor, oh, yeah. What did I do here? Total undeclared. Oh, sorry. Yep, I commented that out, right? Now let's try to rebuild this. Actually, I should have stopped the debugger. All right, once again, run the cursor, let it rebuild. All right, so here's our array filled with variables. All right, we're about to step into sum array. That sum array has this pointer back here to memory. Right, next line, sum gets initialized to 0. Remember, that's important to initialize that to 0 before we start using it in this expression. Right. And we could just step through and we just keep incrementing our sum as we step all the way through the array. Let's just do a run to cursor here. Excuse me. Sum now has a value of 96. Next line, we're going to return back. So here in main, we have that, right, M array still exists. Right. So we just updated that function as well to work with 2D arrays. Right. So 2D arrays, we have to at least say how many columns we have when we declare it, when we use these as parameters. All right. Same way though, when we call it, right, we call this by name. Right. So we don't use any of that bracket notation here, just the name of the array whenever we call the function. That works for 1D and works for 2D. Okay. All right, I think that's about the end of this section here.